Okay, I want to demo the actual use of the server, and you should be able to run this much of the server basically out of the examples um, in the assignment. So you should be able to get this much to work without making any changes to it at all. So we talked about the fact that, I'm running mine. I have to have a separate IP address. You're going to be running yours probably on your local address. So when I put in 192.168.0.36, you're going to use 127.0.0.1 for that address. And the first thing is the configuration where that is set. And that is in an INI file. And it's app config, I think. .ini. There's that IP address on the third line of the file right there. When I check this file in for you guys, it'll say 127.0.0.1 unless I make a mistake, in which case you need to go and edit it and change it. Now, the second thing is the port, and that's the port number that I'm running on. You can choose a different port, choose something above 8,000. Some systems have security that won't allow you to run stuff below that without special permissions. So any number between 8,000 and 65,536 will work, or should work at least. The exception to that is if you're running it on a system that is using your database. The database uses ports 5432 and 5433 usually for Postgres. Other databases use different ports. Those ports are already used, but you've got thousands to choose from. So you can probably just leave that number, and that's the way this example is going to work. Now, I'm going to go ahead and run the server. The very first line in the server, you may have to change because, my install of Python is not where yours is. But you see that second line? If you just delete that first line, this is the default location for Python on most systems. And you can tell where your Python is by doing which Python. Or, so mine comes up with my Anaconda 3 bin, which is where I chose to install this version of Python. The reason why you would want to have multiple installs of Python is because you have multiple applications, and I have multiple projects I'm using this computer for, and consequently, I need different versions of Python for different things. This is the correct version for the class. It's Python 3.8, I believe. This is Python 3.8.3, which is, I think, what I recommended you guys install for the class. And this is the one we should be using. So wherever you have that installed, if it says Python 2.7, it's going to break and not run the code. So you've got to get to at least Python 3.6 something. But if you have a newer version of Python than 3.8, it should work just fine. But anything before Python 3.6 is going to break. The libraries aren't compatible. There's just lots of issues. So that's the version of Python, which means wherever the path is what you need inside the first line of here with the hash bank. If you are on Windows, you will need to actually run it as Python and the A04 server. You also don't have a which command. You're going to have to just know where stuff is installed. I don't know if there's a good search system for Python or for Windows, so you just have to know where it's installed. Again, if you're using a computer that has multiple versions of Python, you're probably going to have to set up some environment variables so that you get to the right version. So let's run the server. And on here, I can just do A04 on your Linux system or on a Mac. And it comes up, one of the things that it prints out when it starts running is it says that it is listening on this port. And actually gives you the URL that you would need to put in. Now, where yours is going to say 127.0.0.1, this says the IP address of my computer that I'm trying to contact, and it has in there 12138, which is the port number that I happen to have chosen. So if we go over here and we bring up this application on that port, first I have to run the server. And you'll notice it gives me the correct URL here printed out for where I want to go and access this server. So let's just copy and paste that in over here. And see what we get. and you'll notice that it goes and gets a whole bunch of stuff. Now, we're going to point out some things that it's doing here. First of all, you notice the IP address that it's sending data back to, that it's printing out. I sent data to this IP address. It has the date and time that it did it. It has the method that it supplied for this request, which in this case is a GET. It has the path that it's actually getting. That's your communication endpoint. The combination of the method and the request is where it's going to end up in the code. And in this case, it says /, which is going to translate to index.html. Windows systems like to use a different default because why not be different and break things so that you're not compatible with the world and people have to use your server. But most of the rest of the world used index.html. And over here is the protocol that it uses, which is HTTP 1.1. There are newer protocols, but they are more complex, and that's certainly 1.1 will work for what we want. It says what the status is. This is a number that gets returned with the request that is whether or not it's successful, an error. No doubt some of you have seen 404. That's file not found status. 200 is success. And if you Google search for HTTP status, it'll give you all of them. There's even one, I'm not a teapot. And over here is the number of bytes that it returned. So you'll see that this file was 15,822 bytes. And then it lists each one of the pieces that the browser in turn requested. We're using something called Bootstrap as a layout. We have this macro template, or this templating engine called Mustache. We use a library called jQuery, and the version is actually embedded in what the library is. And you'll see that it's it's fairly decent size. Compressed, it's way smaller, but this isn't even the compressed version. And when we get down here to the bottom, you'll notice that it has actually done two gets that are endpoints in our code. One of those is get state, and the other one is get severity. Now remember that the state table and the severity table are basically constants that we supply state names and severity. So apparently the application, when it's starting up, just goes out and gets these and saves them on inside the application code. And we can actually see that here in a minute when we take a look at the request that it's done in the network. But what we see over here is that, yes, we have menu items, we have status, we've got some menu things going on. And if you click on status, you'll see that it produces this success status. It says the server is okay, the database is okay, and that you didn't put in any parameters. Now let's take a look at the parameters and how they get passed. Now you'll notice that your communication endpoint is API v1 status. Now what happens if we go up here and put in some GET request parameters where we say that ABC equals DEF and name equals 23, or at 13. 13 works. Okay, we get back the same page because we sent this to just /, but if we tell it that we want to go to some other place like status, that our communication endpoint, we get back the status. It comes back in JSON format, and it has our status information, again with the server status in the database. Apparently it's pinging things to make certain that they're up and running. But we list the parameters instead of empty over here, as it had ABC with a value DEF, and it had name with a value 13. So we can actually get a variable set of parameters returned, and those parameters are things that we have available in the code. We're going to look in the code and see how we deal with these parameters in the code, but you can see this is the format up here. We do a question mark, a name equals a value, right there. And then we put an ampersand and a name equals another value. Up to a certain point, about 1K total length from the beginning of HTTP across, you can supply GET parameters in this fashion. So we can have a communication endpoint /status, and we can send it specific data. Now, one of the things we talked about a little bit ago is that we have different request methods. These are all coming in as a request of GET. GET tends to be something that is both cached and is supposed to be immutable unless you do something otherwise to it. Immutable means that people in the middle, HAProxy, Squid, reverse proxies can just save the value, and provided that you don't change what the request is, it can send back the same value over and over and over. And in the browser, it can cache these values based on this combination of it being a GET, what the path is, what the parameters are. So if we go back to this JS stuff here, where it said JS table, and right after that, here's my API endpoint. Okay. You'll notice that in my API endpoint, /API version 1 embedded in the URL, so that if I go to a version 2 of the server, I can change all those things and guarantee that I'm not getting old, stale data. It says that my thing that I'm looking for is get state, and then it did a question mark and a parameter. And the parameter I supplied was this RAN underscore equals a value. If you go look in the code, you'll see that the front end has a thing where it's actually supplying this sequence number. And that sequence number isn't used on the other side. What it is if I want to guarantee that I have fresh data, I increment the sequence number. So I'd go from 771 to 772. And as soon as I do that, I guarantee that I go through any caching, because now that entire thing has changed, and I reach all the way to the server. So if there's things between me and the server, when I supply that random value, I'm going to blow through the cache, and it's going to go all the way to the server where I have the code and get new data. Now, as long as I don't change the data, I can leave that same number there for weeks, months, years, and things that cache stuff will save it. Now, there's some header files that can tell things, only cache it for an hour, a month, a decade. But it doesn't matter. If I want to make certain I get new data, I supply a new URL with a new value for that random value. Now, later we're going to do stuff where we actually want stuff to consistently communicate to the server, and we're going to use that ability to do a cache burst and get through to the entire server side. So you're going to see where I actually pick off a random value and stick it into the URL. And it won't be a random value like this that changes once in a while when I go in and edit the code. This is going to be a random value every single time it runs it. So it's going to come off the random number generator in the browser and be a big, long number. I think I've used 6 digits in front of the decimal point and 8 digits behind the decimal point as a random value, if my memory serves me correctly. But it's a big number. Now, when it sent back this data, it went all the way to the server and picked off these parameters, turned them into a dictionary, and then converted them back into JSON to get the params. So inside the code, let's go look at that. We're going to see where it is that those pieces of code are, where it picks off the dictionary and the parameters, because we want to be able to say, yeah, I'm going to pick off some stuff, I'm going to get some optional stuff, I'm going to, in my server, I don't care that there's a cache burst random, I'm going to ignore that. Okay, and then I'm going to construct an insert statement with my data and my optional parameters and use that set of parameters. Let's go take a look at that.